Hello everyone. Last time or in the previous video, we learned that great engineers don't rely on memory. They build systems and they think about how to be persistent or how the system can be persistent. All right. Today we'll take the idea one step further. Great engineers also know that even the best systems cannot prevent every mistake. That's why they design for resilience. So the mindset or the topic today is how to think or to make better decisions based on some principle that already exists. And that principle today or that tool today is the engineering behind seatbelts. We all know that in a split second, things can go really bad when it comes to accidents. And the seatbelt entire job is to step in and safely control the kinetic energy using fundamental laws of physics. I'm gonna talk about them, but without being more technical, and we can leave the technical part to a separate video. Uh, Remember here, the goal is to how to understand something. So when we think about a new design, a new system, we can solve the idea and reflect on it and see whether the solution actually fits the purpose. There is a misconception when it comes to engineering that it is about creating perfect machines. Um, while engineering is engineering, uh, we try to create the best machines, but not really the perfect machines because they are limitations. There is a timeline, there is type of a team that's involved, resources, budget, and a lot of things control how the final product is going to look like. So let's just say there is an acceptance to reality, and we need to understand that and work with it. And even when the best machine is created, it wears out. There is weather changes. There are human factors, and there are a lot of other things that are involved. So engineers, when it comes to the idea here, uh, don't ask how do we stop every accident. Of course, there is a set of engineers that's going to ask what is the best technology that we can provide to prevent accidents. But of course, in reality, accepted reality, we can't stop every accident. So the question is, if an accident happens, how can we reduce the damage? And the physics behind this, if you want to fast forward this, the simple way to understand it is an object in motion stays in motion unless acted on by an external force. So now, how this acting or this external force gonna work is gonna be really interesting here. So I'll try to discuss it kind of in general and on the three parts. The first one is the work and distance or the stretch, and that has to do with the work and or work and energy principle. To bring a moving body to a complete stop, a specific amount of mechanical work must be done to remove its kinetic energy. Work is simply force multiplied by distance if you look into the equation. And the seat belts are engineered to stretch slightly during a high impact crash. By stretching the seat belts, increase your stopping distance by just a few crucial inches. Because, and this talking not necessarily the car, but the body, right? Because that distance goes up, the overall impact force applied to your body drastically goes down. The second thing is impulse and time or the slowdown. This ties directly into our the second concept of the crash or impulse and momentum. During a sudden stop, the body momentum drops from highway speed to zero. That change in momentum is fixed and cannot be avoided. However, impulse dictates that force is completely dependent on time. So if you hit a rigid dashboard, your stopping time is almost zero, making the force lethal. So we don't want that. Because the seatbelt fabric yields and stretches, it extends the duration of the stop, spreading the change in momentum over a longer period of time, fundamentally tames the peak destructive force. So here, if you hear longer period of time, it still means very small period of time, but it's longer compared to the instant, right? It's that's just a simple word to say it. The smack uh, is longer. All right. So the third thing, the pressure and geometry. This is also has to do with the pressure equation. That is the force divided by area. If you Because the area is in the denominator, if it's larger, the pressure gets lower. And if you concentrate the force into a tiny area, things will break. This is why seatbelts are wide and flat straps rather than thin cords or something, right? So the wide strap maximizes the surface area of contact. Furthermore, as you know, the belt's geometry is designed to route this force exclusively across the strongest bones in the body, the pelvis and the sternum, and that by maximizing this area and targeting the skeleton or the strongest parts of the body, it protects the internal or soft organs. All right, so this is kind of in general, um, and uh, and of course we can look into the history and how the seatbelts were designed and researched, and we'll understand why they look the way they look now. So engineering, this is kind of a summary, is to manage that energy. The collision involves high energy, and that energy is going to dissipate or has to go somewhere. And the modern vehicles now have a lot of ideas used in them to dissipate that energy, whether it's airbags, whether it's seat belts, and whether the bumpers and how they deform or absorb the impacts. So there is no single feature that does all the work. Safety comes from many layers. If one layer isn't enough, another helps reduce the consequences of an impact. So let's come back to the takeaway after discussing these ideas and understanding them. Um, and the mindset is about designing your own safety system. When you think about a new design or a new product or just your own professional work or just backing up, and the idea could be backing up files, securing a network or a computer, or handling emails, whether spam or phishing emails, or just reviewing an email even before sending it. There are a lot of ideas we can talk about. This is not about just cars. These habits help in making sure a small mistake or an event doesn't become a major setback. So, no amount of planning can prevent every unexpected event, but thoughtful preparation can change the outcome. Engineering isn't really about predicting the future. There is, of course, there is modeling simulation, there is predictive models, and but here the idea is not about uh, tell me everything that's going to happen in the future, and I'll plan for it. That's not really the idea. Uh, the idea is to understand that life is uncertain. No amount of planning can prevent every unexpected event. And so, what we need to do, we need to make sure we need to do our best so we have resilience, whether it's about cars or airplanes or hospitals or computer networks, and share one principle, which is expect the unexpected and prepare accordingly. Expect the unexpected and prepare accordingly. And that kind of takes us to the, the main principle of this video, which is design for resilience. Uh, can't talk about it again. There is a difference between designing for resilience and designing for perfection. We shouldn't seek design for perfection because we don't even know how long will that take. And if we want to make sure things happen within a manageable time frame, we need to design for resilience. And I'll close with this question. What is in the concept of seatbelt, what is the one thing that you can build into your life, into your system, into your new product, whatever you are thinking about, let's say this week or this month, to reduce the impact of an unexpected mistake or unexpected event? Thank you.